Welcome back to the channel. Today's video is going to be all about a design that I came up with myself on making a battery charger. A solar powered battery charger. I'm only going to use this mainly just for trickle charging, and I'm going to have a 100 watt solar panel which will produce 5.5 amps maximum. Most of the time it's less than 5 amps, and one charge controller and 4 sets of battery cables. Now, when you're looking at charging a battery, and all the batteries are different. So I have my diesel tractor, I have my ATV and my lawn tractor, and I'll probably have one deep cycle battery down on the floor that'll charge at the same time. All at the same time off of one system. Now, when you go take a look at buying, say, a trickle charger, you got one set of cables, one battery. And that's because the general idea behind charging a battery, even in my particular situation of just trickle charging it from the fall to the spring, is batteries absorb a charge differently. They discharge differently. And it's the best practice to not have more than one battery hooked up at a time, unless you have a battery bank. Like in my cabin, I've got 4 batteries. They're all the same, exactly the same. They're all attached together, and they charge all at once. What I'm doing is completely different. So, you know, if you've got machines in your shop that just want to charge over the winter time and you don't have electricity like I do, I'm strictly off grid. Well, I think I come up with a resolve. Now, this is part 1. There's going to be a part 2 after I test it all out and make sure that everything works as I designed. Now, you may find this very unique. Let's take a look. I'll take you off the tripod. We'll take a little bit of a zoom around and see what I've used, and then I'll talk about it and we'll test it out. Well, there it is there. We got 4 sets of battery cables. I got my DC power supply, and I just got all the cables looped over here for now. And so I've got this one here is 18 feet long, this one here 16 feet long, and 2 15-footers. I just got them drooped over here for now. And this is the system here, and I'm going to explain how this all works, and we're going to test it out. And for the first time, I'm using these things, and these are called lever connectors, lever wire connectors, and I think they're just fantastic. So now, what I'm going to do before I start anything is I'm going to explain to you that the best practice is if you have one power supply, you can't just hook up 4 sets of cables to 4 different batteries, because they'll all draw off each other and they will not charge correctly. Now, all these cables are independent. They don't actually interact with each other ever. They're just completely separate at all times, except these 2. These are the master cables right here. I'll show you exactly how that works. These 3 here are all independent of this one. This is the master one right here. So if we just take a look here, we'll start up at the top. So I've got a fuse that goes through the switch, and all I need to do now is hook up my my positive and my negative from my solar panel, and they just snap right in here. So this is all fused. So if we just take a look at this switch, you have to turn this switch off whenever you're connecting or disconnecting the battery cables, because this is what the charge controller demands. So these 2 cables here are for the solar panel, and these 2 are for the battery. And whenever you're connecting or disconnecting, you must turn off the solar panel, or you could do damage to the charge controller. Here's the fuse. For this one, 7.5 amp. For this one here is the fuse for the solar panel, 7.5 amp. The only thing on this board that is different, and you're wondering what these are 4 diodes. Each one is 15 amps. Now I ran all my wiring in behind instead of running it over the surface, and this allows me to do this with these type of connectors, and you can see where I've drilled the holes. And we get down to here. So on this side of the system is just the power supply itself. You got your negative and your positive. This is all the negatives to the battery cables, and these are all the positives to the battery cables. 1, 2, 3, except this one, number 4 on that side there. Now, this is the whole idea behind this, and this is just a spare, couple of spare diodes and a spare fuse. So the whole idea behind this is the master charge cable, and you hook this one up first all the time for any part of this system. Of course, you make sure the switch is turned off. So let's start testing here. I'll hook up the power supply and I'll show you the whole idea behind this and how this can charge 4 different batteries at the same time, and none of these batteries actually intersect with each other or know what the other charge rates are except this one. So let's get to it right now. Okay, so I got everything in the shot there, and hopefully you can see that the voltage registering on here. So on a charge controller, all this actually does is read voltage, and it allows amperage to go through the system depending on the amount of voltage that it sees from the leads that go to your battery. And then it adjusts the charge rate, and it'll shut the charge off completely as soon as it reaches whatever charging amount that you can select. These are variable, so generally when this goes up to about maybe 13.8 to 14 volts, it shuts everything off completely and it's fully charged, so it doesn't overcharge, because your solar panel will send about 18 to 22 volts through the system into the charge controller. This drops it down to a proper charge rate that's not going to damage your battery. And so if we just take a look here, you can see that it's lit up and it's showing 13.2. So what is the whole idea behind this? So if we just go to each one of these battery cables, you can see I got voltage there. Go to the next one, I got voltage there, and the last one I got voltage there. Now the whole idea behind this is none of these are actually reading voltage together. What's happening is, if we just go to, say, this is where the power comes in, and you can see the voltage reading there. Now we go over to these diodes. So this is the common ground here, or the common ground here. So if we go to the diodes, you'll take a look here, and you'll see each one is reading voltage. That's only coming from these 2 leads here, the positive and the negative. And of course it is the same when you go to the top, right, straight across the top, right? Now, from your leads, they come up to here. So we've got at this end here 4, 3, 2, and this one here is number 1 over here. So the whole idea behind this is I have the voltage coming in here, and I've got one lead that's going over to here, and I've got the other lead that's going right here. Now, the only power supply is going from here to here, which is number 1 battery cables. These 3 are being powered from these 3 leads here. And this is just a jumper from here to here. And then we have, this is a jumper from here over to here. So the power from the charge controller does not go over to any of these 3. So we've got 2, 3, and 4. It only goes to 1. It goes down through the diode, travels over to this side, and 1 lead goes over here. And I say the other lead is the power supply coming over here from the charge controller. This is the battery cable positive that goes here, and this is the battery cable negative that goes there. Now, you've seen that there's voltage traveling through here. Now, the whole idea behind the diodes is nothing is returned. So when you see voltage on this side, it's only because it's from these 2 leads. Nothing is going back. It's only going in one direction, which is out towards the battery cables. So now let's transfer the leads over to this one. So if we transfer the leads over to number 2, nothing is lit up here. So let's go over to the common ground, and let's just take a look at the output. 0, 0, 0, 0. Up on the top, 0, 0. I don't know if you can get that in a shot there, but it's 0 and 0. Nothing, no voltage is actually being transmitted. Nothing is going on. So I can do this with all the other 3 cables, and it's the exact same. So when you have these 3 cables, 3 separate batteries connected together, none of them transmit any voltage back to the system. It's stopped by the diodes. And we go back to the number 1. Now we have the display back on. So what I did was I had to run 1 diode that's powered off of the charge controller through the fuse. It comes down here, jumps over here, goes over here, gets the power supply feed from here, so that the charge controller has to have a back feed from the 2 battery cables that are attached. And these are the master set here, so these always got to go on first. So how does this all work? Well, this is how it works. Is you hook up the first set, and you'll see a reading on your charge controller. All of these feeds going into the other 3 batteries are all controlled from the master set. So when this goes to charge, it now charges, and we'll just take another look here. I'll just put it in one of the common grounds here. So we've got, see on the meter, we've got voltage going all the way down, the same on every one. Now, this means that these three battery connectors that go to 3 separate batteries are all being operated from this one set of battery cables. So when this goes up to 14 volts and shuts off, it shuts off all of these as well. When it needs to charge this master battery cable set here, well then it also charges all of these. And when it charges up, it shuts off, all because of this master set right here. And that's about as easy of a setup that I could figure out, where none of these battery cables attached to all different batteries ever know that they're attached to the charge controller. The only one is this one here. So this is completely isolated from these 3. They charge all at the same time, all at the same rate. They disconnect at the same time, all from this master set right here. So I'll hook this up to say my diesel tractor, the ATV, and the lawn tractor, and the battery on the floor, which is going to be a deep cycle battery. They will all charge at the exact same rate that it's charging the diesel tractor. And then, of course, when it's charged up, it shuts them all down. So what can you expect for capacity, charge capacity out of this system? Well, the solar panel will be facing south. It'll be completely vertical. I'll show you that in part 2. But the whole idea is, the most I'm going to get out of this is probably 3/4 to 1 amp charge. Very small, that's all you need. What do I have there now at my cabin? I've got 4 separate small little, you know, them small little battery chargers. They have no charge control in them at all. They'll put out maybe, I would say, a 1/2 amp if they're lucky. It's just to charge the battery enough to maintain it over the winter time. I've been using them now for about maybe 7-8 years, and I've never had a problem with them, but I'd like to go to a system that's a little bit better, and I like to go to something that, well, actually regulates the voltage, because when you hook up them small little ones, well, I tell you what, the snow sitting on them or anything else for a couple of weeks, it's a big difference than compared to a 100-watt panel that can you know, last a lot better over the winter time. And I think this is a far superior system. Now I have to actually hook it up, monitor it, and in part 2 we're going to go over that. So what do you think? So let me know in the comments what you think. It might be a lot to absorb, you know, for many that, you know, are not really into electrical, you know, electronics at all, or understand diodes or anything else like that. But it's a very simple system to actually set up yourself. All you need is just 4 diodes, and if you wanted to go, no problem. I think no problem. You can go 6 batteries on 100-watt panel. And leave me some comments down below and let me know what you think about this system, because I've got fellas on my channel that are, well, electrical engineers, master electricians, and the feedback would be really good, you know, and especially automotive technicians that deal with batteries all the time. All of these are isolated. The only thing is, in my mind, that I could think of, what if something happens to, say, the master set that I plug in to, say, I put it on my diesel tractor. Well, whatever happens in that battery with me charging it will affect all the other ones. So that's something to consider. I've never had a problem, you know, trickle charging a battery over the winter time, you know, like nothing ever tragic ever happened or anything. But my idea was I had to make sure that all the batteries were isolated from each other. Because if you hook up 4 batteries, they're going to feed off of each other, and it's going to be imbalanced, and you know, it's not a best practice. So I think I've resolved that. Leave me some comments down below. Let me know what you think. This whole system altogether, I figure, cost me $75 to set up. And you know, if you want to just buy yourself one charge controller, you know, or like say a battery maintainer, they're like $40 a piece, right? And guess what? You have to plug them into a wall somewhere. You have to run them off a power inverter all winter long and leave your power inverter on? No. That ain't going to work for me. This system here, I think, is it's going to work out great. I have to test it. I have to verify first. So stay tuned for part 2. And I got this all set up at my cabin in Northern Ontario. Thanks for joining me here today. Come back again. If you haven't seen this channel before, you're welcome to subscribe. See some interesting things that I like to do. Cheers.